We're moving along with volume today, and we're talking about the volume of pyramids and cones. So we'll start with pyramids. Remember with pyramids and cones as well, we needed to find the slant height when we calculated the surface area. Okay, so that was surface area. We needed the slanted height. With volume, though, so when we're trying to figure out how much space a pyramid or a cone occupies, we don't want the slant height, we want the height. Sometimes they'll call that the altitude, but most of the time it's referred to as just the regular height. Now, the height is the perpendicular segment from the vertex to the base. In other words, they're just going to go from the point at the top and they're going to drop the height straight down so it makes a right angle with the base. Okay, so they could still give you the slant height, but to calculate the volume, to use the formula, you need the height. Now, the formula for the volume of a pyramid, it's the same idea for the most part as with prisms and cylinders. So remember with a prism, it was area of the base times the height. Now, obviously a pyramid does not hold or take up as much space as a prism does. It actually occupies a third of the space that a prism with the same base would. So the formula is 1/3 the area of the base times the height. Okay, and if you want to see kind of more where this comes from, there's a video that I could show you, and it would kind of give you a visual of the volume of a pyramid being exactly 1/3 of what the prism with the same base would have. Okay, but it's similar to prisms in that you only need the area of the base and the height to find the volume. So let's use this formula for example 1 and 2 here. Now, number 1, the base, the bottom, is a square. So let's get our formula going here. 1/3. The area of the base obviously would just be, it's a square, so it'd be 40 times 40, which would be 1600. And remember, you need the true height, not the slant height, to calculate the volume. They've given us the slant height here, so we need to use this little right triangle to calculate Pythagorean theorem. Be careful. People will say that the bottom of the right triangle is 40 right here, but remember that it's half of one of the sides, so it's 20. So my Pythagorean theorem would be h squared plus 20 squared equals 25 squared. So if I plug that into my calculator, I have h squared equals 225, and then the square root of 225 is 15. All right, so the height is 15. So that's the last piece of the volume formula that I needed to fill in. So you could do 1/3 if you have a calculator like mine, just one fraction button, 3, times 1600 times 15. And that would give you 8,000 cubic feet. If you don't have a calculator like mine, I would plug it in like this: 1600 times 15, get that number, and then just divide it by 3. Dividing by 3 is the same thing as multiplying by 1/3. All right, on example 2, so same formula, 1/3 times the area of the base times the height. So the area of the base, we'll do that up here. This time the base is a triangle, and it's a right triangle, so I'd do 1/2 base times height. So the base and height would be 14 and 8. So big B is 56. And the height of your pyramid, and they gave that to us. They didn't give us the slant height this time, so they made it a little bit easier. The height is just that 17 there. So I can calculate my volume, 1/3 times 56 times 17. Gross number, but that's okay. This is 317 and 1/3. They didn't tell me how to round it, so I'm just going to leave mine like this. units cubed. And guys, I'm going to make one last note on the front here before we flip it over. Remind yourself that with pyramids, just like prisms, big B, how you find that will vary. Okay, so like on number 1, the base was a square, so I just did length times width. On number 2, it was a triangle, so I had to do half base times height. So depending on what kind of pyramid it is, that will tell you what formula you use to calculate big B. All right, so that's pyramids. On the back is finding the volume of a cone. Now, cones and pyramids are similar, and they're almost exactly the same, except the difference is that instead of the base being a polygon, so in a pyramid, the base is a square, it's a hexagon, a pentagon, whatever. In a cone, the base is always a circle. So the formula is similar. It's got that 1/3 because a cone can occupy a third of the space that a cylinder with the same circular base would have. So it's 1/3 the area of the base times the height. Big B, you guys, right here. In a cone, the base is always a circle. So instead of saying big B, they're just going to plug the formula for area of a circle in there, pi r squared, times the height. So area of the base, pi r squared, times the height. And take a third of that. All right, we know that it's radius and height that we need, so let's calculate this on number 1. All right, so 1/3 pi times, let's see, they're trying to show me right there that the radius is 10. 10 squared times the height. Now, this kind of looks weird because this is called an oblique cylinder when it's like slanted, or sorry, oblique cone when it's slanted. So when they draw the height in, they go from the vertex and they just drop it straight down. So this is the height right here. Even though it's outside of the cylinder, that's okay. It's that perpendicular segment, so that's what I want right there. They want me to write my answer in terms of pi, so they nicely gave me everything I needed. I'm just not going to put pi into my calculator. So that'd be 533 and 1/3. Stick the pi back on. Centimeters cubed. All right, that was kind of nice when they give us everything. Number 2, they might have made it like one step more difficult to find the volume, but I still just need the radius and the height. So they're giving me the radius is 3. This time though, they gave me the slant height, which is this 7 right here. I want the true height, that perpendicular segment in the middle there. Okay, so we're going to have to do Pythagorean theorem. So it looks like h squared equals 40. And they want me to leave it in terms of pi, so here's what I'm going to do. I'm going to factor tree this down, because it might say simplest radical like on an exam, so it couldn't hurt just to kind of roll with that and remind ourselves factor trees. So this would get rewritten as 2 would come out, 5 and 2, so 10 would stay under. Okay, so that's the height, which I'm going to stick right here. And, ooh, we've got a pi and a radical. So I'm going to leave both of those out of my calculator when I plug this in. So I'm going to do 1/3 times 3 squared times 2, which is 6. And then I'm going to stick the radical 10 back on, and then stick the pi back on, and that is my answer. That is a pretty answer.